Hi students, we're going to talk about the slope of a curve, which is also called the derivative. So, we've kind of talked a little bit about limits and things last unit and slope. So the slope of a curve at a point P is the measure of steepness of the curve. So remember we had a point PQ and we found the slope and we used our limit definition. So, just to review, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so that's how we find the slope. And that's when we want to find the slope at a certain point. So, looking at our first example, we already did this. So, you're going to try this example, and if you need help, I am going to do the second example with you. So, in the second example, it says find the slope of the graph, a line, actually it should be parabola, y equals x squared near any point x squared. So basically, I'm going to pick any point on the curve and I want to know what the slope is. So the first thing is, what is the coordinates of Q? Well, P is x and x squared. So Q, we're going to go over a little bit of a distance and we're going to call that h. So this is kind of reviewing what we did last time. So Q is going to be x plus h and then x plus h squared. So in other words, we're plugging in x plus h for x. So now I want to know what the slope is at PQ. Well, we're going to do our limit formula. So limit as h approaches 0 of f of x plus h minus f of x all over h. So that's my formula. Okay, so again, we're plugging it in. So if I plugged it in, it would be x plus h squared minus x squared all over h. Okay, so x plus h squared, I'm going to do this off to the side. We would double distribute or FOIL. You should get x squared plus 2xh plus h squared. So I have x squared plus 2xh, h plus h squared minus x squared all over h. So what's going to happen? My x and my x squareds are going to cancel out. So I have the limit as h approaches 0 of 2xh plus h squared over h. And remember, we want to cancel the h's out, so I'm going to take out an h, 2x plus h all over h. The h's cancel. So again, the limit as h approaches 0, now I'm going to send my h to 0. So if this is 0, I get 2x. So what is the slope? The slope is 2x. So if I can pick any place on the graph, my slope is going to be 2x. What does the answer represent? The slope anywhere on y equals x squared. And what's another word for the slope? Derivative. So slope and derivative mean the same thing. So what we just did here, again, is slope. All right, so here's what I want you to do. Think about it. I have the equation y equals x squared. The derivative is 2x. What could be a shortcut rule to find the derivative of any polynomial? Think about it. If f of x is x to the n, then the derivative, because f prime, this means derivative or slope, is n x to the n minus 1. Again, we'll explain that in a minute if you don't understand. What do you think the derivative of a constant function is? Like y equals 3. So think about it. I have a graph, y equals 3. What's the slope of that? If it's any kind of number, the slope is 0. Remember, the derivative is the slope of the curve. Okay, so let's try some examples. Before we do examples, we're going to do a little bit of review from last year. Remember radical x, power over root. The root is a square root, so that's a 2. That's a 1, so it would be x to the 1/2 power. If you have a fraction, we're going to rewrite it by moving it to the top, so that'd be x to the -4. Whenever you move an exponent, it becomes positive or negative. It becomes the opposite. Okay, let's try some examples. We're going to use the power rule. So basically, the rule said n x to the n minus 1. So in other words, you take the power, you move it to the front. There's already a 5 there, we multiply. 10x, and then this says subtract 1 from the exponent, so it would be 10x to the first. This is a 1, right? If I move it to the front, 3 times 1 is 3. And then it'd be x to the 0, which is 1. So my answer is 10x plus 3. Okay, I'm going to do number 3. Before I do anything, I'm going to rewrite this. So this is 5x to the 1/2. Move your exponent up, it'd be negative 10 minus 10x to the -2. And again, this is 1/2, and I want to move it to the top, so it'd be minus x to the -1/2. So I rewrote it first. Now I'm going to do the derivative. So the 1/2 goes in front. 5 times 1/2 is 5/2. And you can keep it as a fraction. It doesn't matter. And then if I subtract 1, I get -1/2. Okay. Again, multiply. -10 times 2 is positive 20. And then we subtract 1. So that's, or I'm sorry, we subtract 1. And then again, we move into the front, positive 1/2, x to the -3/2. Okay, last step, we want to rewrite that. So I'm going to rewrite that. So I have positive exponents. So the x would move to the bottom with the 2, and it would be under a radical. Again, 20 stays on top, x moves to the bottom, becomes positive. X moves to the bottom, and in a radical, power and root. So it's a square root with a 3. Again, this is review from last year. Okay, try number 2 and number 4 using the rule we just did. Okay, now we're going to do the same thing, except we want to know what the derivative is at 2. So f prime means derivative. So I'm going to do exactly what I did before. I'm going to find the derivative first. So the number goes in front. 3 times 3 is 9, x squared plus 2. Now, this means plug 2 into the derivative. So 9 times 2 squared plus 2, 38. Okay. Try number 2. You should get 27 as an answer. Okay. The last rule we're going to do is the rule for the exponential functions. This also means derivative. Okay, that's just another way it's written. So this df, dx means take the derivative in terms of x. So the derivative of any exponential function is the same and then ln of the base. So it's going to be a to the x, ln a, and then anything with e to the x is e to the x, because ln e equals 1. So e to the x ln e is 1, so it's just e to the x. All right, I'm going to try number 2 and number 4. So if it has a constant in front of it, the constant stays. So see this number? It's going to stay. Okay, we're going to do the derivative of 5 to the x, which would be 5 to the x ln 5. And that's it. Let's look at number 4. ln 2 is a number. The natural log of 2 is a number, so it's just going to stay. we're going to do the derivative of e to the x, which is just e to the x, minus, we're going to do the derivative of 8 to the x, it's 8 to the x, ln 8. Okay, try number 1 and number 3, and we'll go over those in class. Okay, and then I'm going to do number 6, same thing we just did. We're going to do the derivative first. So again, ln 3 is a number, so ln 3, whoops, let me rewrite that. ln 3, derivative of e to the x is e to the x, minus 2 to the x, ln 2. Now it says find the derivative at -1. That means plug -1 in. So ln 3 e to the -1 minus 2 to the -1 ln 2. Okay, so if you left your answer like that, that would be the answer. And if we plug it in, we're going to go 3 decimal places. So 5.285. That should be, nope, that's the answer, actually, to that one. The answer to this one should be 0.058. And that's rounded to 3 decimal places. So I gave you the answer to number 5. Try it out. And that's it.